project as a role of principal investigator. He has also organized many workshops, trainings at National Institute of Technology, Nagaland. He has a great contribution in research and development activities. He's having 2 patents on his name. One is filed on 5th May, another is on 13th March 2021. Dr. Das is having more than 40 publications in national and international journals and more than 60 publications in international conferences. He has encouraged many research scholars. He has guided 4 doctoral students and currently guiding 13 research scholars for their doctoral degree. It is an honor to have you here with us, sir. Now I request Dr. Das to start the session.
Thank you, madam. Thank you, Dr. Asabhave. So before I will start my sessions, I want to give my special thanks to Department of Applied Science and Humanities, MCT's Rajiv Gandhi Institute of Technology, for conducting this workshop. And my sincere thanks to Dr. Neeta Kapse and Dr. Pallavi Mahale for inviting me as a resource persons. And it will give me immense pleasure to interact all of you. Most of you are faculties. So it's not that I will have my sharing of knowledge. I think you might have all those things, but it will be a refreshment and a discussion among ourselves. And so before I will start the session, so I will request that I will switch off my camera, which may take some data. So I will switch on my only audio, okay? And later on, when we will have interactions, at the time I can have it. So thank you, madam, and thank you to this institute. So before going to the it's a faculty development program for recent advancement in nanomaterial and green technology for sustainable energy. So here, most important thing is that we will discuss about the maximum power extraction from PV system. I will be focusing on PV system, how the maximum power can be extracted from PV system. So before going to this, what the technology that we have developed, and it is also many people are developing on this. So I will have some introduction. So let me start with this. All of us know that what the energy is. I think 1 minute. Okay. So what a energy is. So we know that in physics, energy is the quantitative property that must be transferred to a body or physical system to perform work on the body or to heat it. So we know that how much important energy is in our life. So if I want to deliver a talk, I need energy to talk. If you want to attend a workshop, you need energy to attend that workshop. If you want to control the temperature of your room, then you need one device which will control the temperature, and that device requires energy. So to do any work in everyday life, whether we are human or a device, we require energy. That is the importance of energy for us. Without energy, we cannot even work, we cannot even move, and we cannot have all those lives. So energy has a very much importance in our life. And we know that the most important property of the energy is that it is conserved quantity. Conserved quantity means it will neither be destroyed nor be created. It can only convert from one form of energy to another form of energy. Now the topic comes, in which form of energy that we require energy. Because we know that there are many forms of energy is there. If we will go to the resources, there are many forms of energy that is available with us. It is in the form of heat. It is in the form of fossil fuel. It is in the form of coal, natural gases. It is in the form of solar energy. It is in form of the hydropower energy. So energy is available with us in many forms. But what form of energy that we require in everyday life? That is very, very important. If we can see that in everyday life, most of the energy that we require are electrical energy. Most of the appliances, if I want to switch on my refrigerator, if I want to switch on my washing machine, if I want to press my dress, I want if I want to grind my anything, any substance, everything, that every work that I require electrical form of energy. That is one of the most important form of energy that we require everyday life. Because why I require such such form of energy? It will make our life easier, nothing else. That is the objective of our life, that how we can make our life easier. I want to move from one place to another. I may take a vehicle which will take me from one place to another. I may use some energy, some form of energy which will rotate my wheels so that I can move easily. I want the temperature of my room should be at in summer I require 15 degrees Celsius or 20 degrees Celsius. I will use one air conditioner. So in this, if you will think, in all sort of energy that we require, all form of that sophistication we require mostly electrical energy. All the appliances, most of the, you can see that 90, if I want to use my mobile, I have to charge my mobile. It has to be energized such that I can communicate with somebody. That if you see, every form, most of the form of energy that we require is in the form of electrical energy. But is this energy, the electrical form of energy, is available in the same electrical form of energy in this world? No. So we can see that we got solar energy. So we got this energy from different sources, and that sources has to be converted, because we know that energy can be converted from one form of another with so that I can get the electrical form of energy, and I can use that electrical energy for my my appliances, for my convenience, or for my easier, or my good for anything that I want to use. So such type of energy conversion I can do. But the energy that which is available with us from the nature is not in that form of energy. So what the energy, basically, if we will categorize the sources of energy that is available with us, it can be categorized with non-renewable energy and renewable energy. So these are the sources which we can categorize. If you say that why it is non-renewable and why it is renewable, renewable means I can reuse it, and the amount of energy is enormous. It will never adjustable. I can use some form of energy which is available with us, it can be adjustable. So such energy cannot be used or cannot be reused in the same form. So, and some of the energy which is available to us can be reusable, I can use it, and and they're not existable. So if you will categorize, you can see that the form of energy that is available, which are the fossil fuels and nuclear energy, coal energy, natural gases, all those energies are non-renewable energy. They're existing, they're adjustable. So it's slowly we are unable to, you can reuse it. And so slowly the fossil fuels, the coal, these are adjusting. So I cannot use after certain time I cannot reuse it. I cannot use it for my source of energy that I require, because I require electrical energy. Most of the appliances that which has to be energized is in electrical form. So I cannot get that source from that, after certain, time, after years, I think after 50 years or 100 years or 200 years, it cannot be used. The availability will not be there. But I have to search for an alternative which can give us the energy which is non-adjustable. So such type of energies are called renewable energies. What are the renewable energy? We know that the sun, which is, it is a source of, huge energy. Okay. And the hydropower energy, the power, the energy that is with the water, the biomass, the wind energy, the geothermal energy, all the tidal energy, all sort of energies which can be reused, and it will never exist. It is not exhaustible, non-exhaustible. So I can use it again and again for my requirement. Basically, our requirement, let us think that what is our requirement. Requirement is that we need renewable energy or any form of energy to convert it to electrical form of energy to do or to energize my devices. So this is our objective. So these are the two forms of energy that is available with us. And we know that some of advantages are there, some disadvantages are also there. So let us see that what are the limitations of these conventional sources available with us, because I cannot deny that still we have national thermal power plants are there, many nuclear power plants are there. I cannot deny that whatever the power that we are getting, most of the power are coming from the national thermal power plants. So the power plants has been established, and which is using the coal, fossil fuels, and these are the sources or energy sources which has been used by the different states or the center to generate power, and which has been supplied to us. So that we cannot deny. But if we will think for the future generation, it may be adjustable. So that's why, but we will see that what are the limitations are there in this conventional sources of energy sources. The limitations are that it is limitedly available. That means it cannot be renewed. So the availability is limited. It is it is adjustable. And another one is it has one of the most major issue is that environmental issues. What environmental issues? So now we are much bothering about the environmental pollutions. So this is one of the major issue which is connected with the conventional sources. Whenever these conventional sources are being converted to any form of or any other form of energy, that is basically electrical energy. So during the process of conversion of energy from one form to another, that is to electrical energy, we used to get some pollutions, or you can say that some hazardous gases like carbon monoxide, carbon dioxide, sulfur dioxide, all those kind of hazardous gases has been generated during the conversion of the energy. So it has an environmental issues. Another one is centralized energy sources. We know that here you might have heard about that there are in a very prime locations or very specific locations you have the thermal power plants in some of the states, like in Odisha, in Bihar, in Madhya Pradesh, in maybe in the Maharashtra. So these thermal power plants are very near to the coal mines, or some wherever there is a resource of energy resources like coals. All those resources are there, and what it does, from the coal resources, from the whatever the energy resources, it converts to electrical energy, and from the electrical energy it is transmitted to different places or different locations to the consumers to get the energy and energize their devices, and to their house, to enlighten, to start their motor, to pump. All those things has been used. So that has been transmitted from electrical energy, has been transmitted from one centralized place to another locations. So there are many factors associated with the distribution of the power or the electrical power from one location to different location. So what happens, there are many power losses during the transmission of power from one centralized location to another location. That is one another major disadvantage of centralized energy sources. That means wherever the energy has been generated, electrical energy has been generated, and it has been transmitted to different locations, it during the period of transmission and distribution, there are many losses occurred. That is what we don't want. The power has been there is a loss of power during the process of energy transmission. So that is what the limitation of conventional resources. Another one is energy security. Here, as we know that it is adjustable, it is not secure. So sometime, or one today or tomorrow or in some day, it will come when we will be adjustable with all those resources like fossil fuels. We may not have all those sources. So there is a thought, okay, because we don't live for ourselves, we live for the next generation. So when we think about the livelihood, we must think about the future generation, how the future how the future generation will be get the livelihood and proper energy, because energy is the source of everything. But these conventional sources are not secured. So sometime today or tomorrow or a day after tomorrow, someday it will be adjustable. So we must have to find an alternative. So next one is that limited efficiency due to multi-step conversion. What is that? The efficiency reduces. Whenever I told you that, whenever basically, let me tell you about what are the different conversion that we do. Let us take it to a thermal power plant. So what we do, we bring the coal and some that for fossil fuels, and we used to generate heat energy by burning this fossil fuels, and that is the conversion of fossil fuel this energy to heat energy. Then that heat energy is being used to heat the water, and the water is being converted to steam, and the steams are used to rotate the propeller, or you can say turbine. Through that turbine, you can say there is a device which we call synchronous generator. Basically, the generators are the devices which will convert the mechanical power to electrical power. So whenever this mechanical energy through that steam, which will rotate the turbine, it will generate I am not going in deep into that energy conversion. So you can see that we have the generators, which we are using the synchronous generator for generating AC power, alternating current power at the power generators like NTPC, many hydropowers. The hydropowers, they are using the water. But let us go to that non-conventional sources like burning the fossil fuels, and through that the steam is rotating the turbines and it generates the heat, through heat energy to the steam. Then steam is rotating the turbine and it generates the electrical energy. And during the process of energy conversion from heat, then steam energy, then it converts to mechanical to electrical energy. The multi-step conversion of energy happens, and again in a centralized place, again the energy is being converted or transmitted. So in this multi-step conversion of energy is not efficient, because you see that in every stage of conversion we will find some amount of losses, power energy losses during the conversion from one to another. So when there will be multi-step conversion, the amount of energy loss will be more. So these are the limitations where we are not, for which we are not encouraging the conventional resources. But nowadays we cannot go beyond that. Whatever the resources we have, we are using it. So, but these are the limitations or the disadvantages with the conventional. So let us see that if these are the limitations, is there any, we can see that with, is there any advantages of this non-conventional resources on this, over this? So advantages of this non-renewable resources. What are the non-renewable, renewable energy resources? So let us, the first thing that we want, that we want to be, we want to go green. Now the mess, I think whatever the theme of this, workshop is to go green. Now, most of the important thing is that how we can go for, how we can solve the, like environmental issues, how we can reduce the pollutions. And this is one of the most important factor that has to be addressed by us, as that in future generations will be in a proper, get the proper air, proper water on the proper resources. So this is what the address is now the current generation is having. So to go green, we require, we must know what are the advantages of this renewable energy sources. First advantage is that it won't run out. That means it is non-existable. It is a enormous energy or a non-existable energy available with us, such that we can use forever, and it will never be exhaustible. So whatever the requirement of energy, because most of you know that we require electrical energy. So whatever the renewable energy sources available, that we can convert every time. Neither we nor all of us in our future generation also can use this, renewable energy for their livelihood, for better life, all those things. So it is a non-existable, energy sources. So renewable energy has a lower maintenance requirement. So another, advantage is that it has a lower maintenance requirements. So if you will go to the renewable energy sources, it has the maintenance is more, because the industrial setups and the maintenance that we require for the devices is high. But in case of a non-renewable energy sources, the maintenance or the maintenance cost associated with the renewable energy sources less. The cost involved in the maintenance is less, and it will definitely, when the it will maintenance is less, it will save our money, and it will be cost effective. The renewable energy has its numerous environmental benefits. This is very, very important, because that is because the theme of the workshop, and now the government of India and the whole world is now addressing this concern, how we can save the environment. Because if we cannot do it, then tomorrow it is very difficult for the generation to live in this world. So and how to go green, this is the address, how we can replace the conventional energy sources with renewable energy sources, which has a less hazardous effect or a less pollutant to the environment. So another one is that renewable energy leads to cleaner water and air. So definitely, when it has a good environmental effect, so it leads to a clean water. That means it will never give the pollutant which will pollute your water. And another one is air. So these are the two things which is associated with the environment. And renewable energy will create jobs. So let me talk about this now. How? Because now self-sustainability, because sustainability is also one of the theme of this workshop. I can say that the sustainability we also require for the young generation nowadays. So if this renewable energy, which is a decentralized process of installation in our areas, in our village, in our city, in everywhere, so this will create jobs for the young generations for entrepreneurship, and also for the those who are not having any jobs, they can go for such installations for the renewable energy sources by getting some government incentives. Because in our country there is an institute called National Institute of Solar Energy, nice, NIC, National Institute of Solar Energy, which encourages the installation of this renewable energy sources. Also it has a role to train the young people to install or to be an entrepreneur in the sector of renewable energy, in the sector of PV system, or in the sector of renewable energy sources in the solar energy sectors. So that which will lead some job generation and also entrepreneurship. And renewable energy can cut down the waste. So definitely there are we can use the biogases and biodegradable product, definitely. So it has an effect to the waste. So it will definitely cut down the waste. So these are the advantages where the renewable energy is having over the conventional energy. But some of the disadvantages is there, but that disadvantages is very, very less. Like the installation cost is there. So such things can be addressed in many of the installations of solar energy, which will be which I will discuss how somebody can go for the PV system installation. So such things can be addressed, or the cost effectiveness can be addressed. So these are the advantages. Now we'll see that where our country is now regarding, because we know that when we talk about the renewable energy and non-renewable energy, we must know where we are, where our country is now. So some statistics related to our country. So if you'll see that our country is world's third largest consumer of electricity. We are in third largest consumer of electricity, because you know that the population is nearly more than 130 crore. So you can now think about that amount of the consumption of electricity the consumption of the number of devices that you are using, every individual is using. Nowadays, every individual is having a mobile, you require to charge. And everywhere we require, electricity. We require we have all the devices in our house. So we are the third largest consumer of electricity. How much we are expecting? We are using 400 gigawatt. It is being 373 gigawatt of power that we are using, electrical power that we are using. But out of this 373 gigawatt of power that we are using in 2020 statistics says 38% of the energy, that is nearly 136 gigawatt, is being generated by renewable energy sources. So we are not lagging in the direction of the renewable energy producer, because we are in that direction, and our objective is that our next generation, our country should give without using the conventional energy. We will be self-sustainable, and our whatever the power, electrical power that we use can only be generated by the renewable energy. That is the target. And we are in a very positive direction towards that, to achieve that goal. And if you see that in 2021, we are the country getting the Ernst and Young Global Limited, and for getting that renewable energy country attractiveness index, ranked India third behind US and China. So we are in the third position in the world to generate the renewable energy sources, for our, for all our loads for all our, country. So this is all about the statistics. We can see that. Now we'll see whether our country, what is basically target is. If you see, this is the current scenario, what the target we have. Now, in 2020, the renewable energy target we have is 175 gigawatt. So what out of this 175 gigawatt, so it includes 100 gigawatt of solar power, 60 gigawatt of wind power, 5 small hydro, and 10 gigawatt of biomass power, and 0.168 gigawatt of waste to power. So this is the target that we are having in 2020, and in 2030, basically we want to replace. Basically, this is the target that we have, that we want to replace the total power, or a conventional power that has been generated with a renewable energy power. So now we can say in 450 gigawatt of power that we want to generate from the renewable energy sources in 2030. So this is our basically the target. We don't know the slope with which we are moving. We will be able to achieve in 2030 with this amount of renewable energies. And the awareness that has been created by the ministry, that has been created by many academicians like you. Your institute is making aware about the green energy, all sort kind of awareness programs, and the awareness programs by the National Institute of Solar Energy. So they are conducting a Surya Mitra program, and in each village, each small village, they are conducting the awareness such that they will be self-sustainable, and the amount of power that can be generated by the small villages only by the solar energy. So this is the target, and we are moving in a very right path. We are moving in a very positive slope to achieve the 450 gigawatt of power in 2030. So this is our target. Let us see that if this is the power, are we having such kind of resources in India or not? Because I will make the target, we will make a target, but we have to see that are we capable of achieve the target or not. Let us see that is India is having such kind of availability of power, of renewable power is there or not. Because without having that capability, we cannot set only a target of 450 gigawatt. Let us see that where we are. Solar resources in India. So if you see that if we will take a statistics, 300 days, we have a clear sunny days in a year. So you will find most of the days, and if you leave some portions like in the northern part of India and northeastern part of the very northeastern part also it is there, but in the northern part of living to the northern part of India, you'll find most of the places in India, 300 years, nearly 300 years, we have a clear sunny days. And if you will see that approximately 500 trillion kilowatt power of energy is being incidenting from the sun to our land. So you can see that the huge amount of power, huge amount of energy that we are receiving from sun. So we are having the capability, we are having the resource now. To that we are the incident power on us is incident energy from the sun is nearly 500 trillion kilowatt hour per hour. So we are not even using the some 1% of that. The solar energy available in a year exceeds the possible energy output of all fossil fuel energy reserves in India. So the daily average solar power plant generation capacity in India is 0.25 kilowatt per meter square. So you can see from the statistics, and which is equivalent to 150 to 200 peak capacity. So you can see that whatever the amount of energy that has been incidented from the sun or a solar energy, we are not even using that much. We are using very less amount of energy for converting our from solar energy to electrical energy to any other form of energy. So we have the resources now how to utilize that resource such that the amount of that energy can be optimally used for our for our uses. Okay, let us see that let us see the trend of install the capacity, how we are doing in our work. So India set a year-to-year target to reach the ambitious 2020 solar goal. If you'll see in this 2020 goal, we in 2013, if you want to see our progress, the installation is 1.9 gigawatt, and we are increasing exponentially. In 2020 the target that we are going to achieve is 100 gigawatt of solar power or PV power. So this is what we are in a exponential increase of the generation of energy from the solar power or from the PV power. So now see, we have the resources, and mostly when we talk about the non-renewable energies, the best resources that we sun is the source of all energy. That's why we praise sun. Okay, we worship sun. That is only the reason why we worship sun, because it is the source of energy. And if we will use that energy for us, it will give us everything, health, wealth, everything. So what we do, our ancestor also knows about this, but we are utilizing this one for all our uses, starting from our whatever the the work that we want, we can utilize the solar power. Now what to do when the solar energy is available? How can I get that energy for my convenient form of energy? Because I know that, and all of us know that only the most convenient form of energy which is required for our daily life is the electrical form of energy. Because everybody knows, starting from a mobile recharge to starting from pressing my shirt, pant, and to wash my dresses, and to cook my food, and to many things that we used to do, it is possible by electrical form of energy. And that electrical form of energy, if I will receive, if one day if there will be a power cut, then we know that what is the scarcity, what is the importance of the electrical energy that we want to receive, that we require in our daily life. So how I can get the convenient form of energy from from the solar power? So it is only possible if I can convert the solar power to electrical form of energy. So how can I do it? So there are three different technologies that is there to convert a solar power to electrical power. The first one is solar thermal energy plant, by installation of the solar energy plants, then concentrating power plants, then photovoltaic solar energy plants. Let us see that what are the one by one. Let us discuss about that. What is the types of solar plants available? What is the technology behind this? So thermal solar plants, basically this is basically a heat dependent solar technology. So that was used in solar power plants. In this technology, the sun rays are focused to a point by using solar collector so that appropriate high temperature can be obtained to generate electricity. So let me explain what it is. Thermal solar power plants. Basically, the concept of this solar power plant is to collect the solar power or solar energy, and from that collection of the solar energy, that can be converted to heat energy, and that heat energy will heat up the water, and the water will be converted to steam, and the steam power will be used to rotate the turbines, and the turbine, by rotation of the turbines, I can generate power, or I can convert the mechanical power, the rotary mechanical power, to electrical power through synchronous generator, and that power can be generated, electrical power can be generated and transmitted to the consumers. So this is basically the theme, or you can say basically the working principle of this thermal power solar power. What we'll do, let me explain, go to the next level. So you can see that there is a photo in the left hand side. So there is an installation, basically a huge amount of area is used. A huge area is used, a large area is used for installation of the solar collectors. So these are the solar energy collectors. What it will do? So these collectors will collect the solar energy, the sun energy, and they will be reflected to another collector. So there will be another sun, solar collector. So this reflection of this energy, or the collection of this energy, will incident on a point where the complete solar energy will be collected, and that amount of energy is used in the form of, it will be converted to heat energy, and that heat energy is used to convert the water to steam, and again that steam to all those process has been done to generate the electrical power. So this is the concept of, or you can say the basic principle of using the thermal solar power plant. So here you can see that in the right hand side, so there are concentrated solar power plants. So these are also basically the lenses and mirrors, tracking system to focus a large area of the sunlight into a small beam. What they will do, a large area, because it is like a mirror or a lens where they will collect, and these collection will be incident upon a single point, and that single point will convert it to a heat energy, and with the conventional, the way that I explained to you that how the heat energy is being used to convert the to change into a electrical energy, with the same process the power generations can be done. So the next one is in the next type of the solar energy is called the photovoltaic cell. You might have seen that there are installation of the photovoltaic cells. So if you see in the previous two approaches, one is thermal solar power plant and another one is concentrated solar power plants. These two are centralized process of power generation. So centralized power plants are there where they collect the power or generate the power and distribute to the consumers. Now this is the power plant which can be used in decentralized way. So here you see we are installing the PV panels. I will go to in detail about the PV panels, but here this is the power. This is the system where the PV panels are there, and the PV panels are used to collect the solar energy, and that solar energy is converted to electrical energy and it is distributed to the consumers. Now you can see that why I told it is a decentralized way of generation of power. Okay, now if you'll see why it is decentralization of generation of power, because I can use a solar panel anywhere in my house, in my village, in my town. If I want some 1 gigawatt, kilowatt of power for my house, if I want only 2 kilowatt of my power, I can install, if I have the facility, I can install a PV system in my rooftop, and I can generate the power. I can charge my UPS. And whenever there will be no power from the grid, that power can be used by me in the night time also, I can connect a battery and I can use that power in any moment. So that's why I told you it is a decentralized way of power generation, and it is most advantageous for the power generation. By it can be in any scale of power generation. Somebody can go for only 1 kilowatt of power. Somebody can go for, if a industry for a village, if you want, you can go for a megawatt of power. If you want a big scale power generation, you can go for a gigawatt of power generation. I think this is the advantage, what it is there in the solar photovoltaic solar power plants. So before going to that, let me show you that some of the power plants which has been, how that is being done in case of a, thermal solar power plants. So I think am I able to clarify, or am I able to share my knowledge? Is it okay? Am I audible? Clear?
Yes, sir.
Okay. Thank you.
Yes, sir. Yes, sir.
Thank you very much. Thank you.
Perfectly audible and very, very clear.
Okay. Thank you, madam. Then I will continue. Okay. So now you can see that. So this is one, schematic diagram for its, thermal solar power plant. What I explained you now. You see, so there are some solar collectors. Let us go to the left-hand side of the figure. Okay. So if you will go, there is solar collectors. On the solar collectors, there is a pipe, metallic pipe is being passing through that solar, which is in color of metallic pipes are there. You will find whenever. Yes. Yes, madam. Yes. May I?
No, sir. Continue, sir. Continue.
Okay, sir. Okay. Thank you. So you can see that these are the solar collector in the field. So there is an installation area where we will install the collector field, and over this solar collector we can have the pipes are metallic pipes are being fixed. Through this metallic pipes, water will flow. The cool water will flow. So now what is the process that we used to do whenever in the sunny weather, whenever there is a heat or sun or the solar energy will incident on the solar collector, it will collect the energy, and through that energy, through that reflector, the heat will be given to the metallic pipe. Now you see, whenever the input to the pipe is a water is cool air, cool water, but once it will go through that solar collector field, the solar collectors, it will be heated, and through that it will go to that. I will just skip, and it will go to the, I can say that it will, through which it will go to the hot tank. Then it will be converted, that hot water will be converted to steam through superheaters and the heaters, and through vaporizers, and through that superheater the steam is being the steam is generated, and the steam energy will rotate the turbine, which will create a mechanical energy, and this mechanical energy is converted to electrical energy through a generator, which we call it as a synchronous generator. Now you see that synchronous generator, three-phase generator is being, the power is generated, electrical energy is generated through the transmission line. We will be able to transmit the power from different locations of the consumers. Like in a particular place, it is there through which we can generate the power, and from different location of the consumers, it can be transmitted through transmissions line. And these are the, you can see that this is basically a working, how it works, and basically a reflector is there, and these are the different types of reflector, how it works, and different types of reflector and observers are there. These are the schematic diagram of the reflectors and observers for thermal solar power plants. So you can see that the similar concept, basically the concept is very similar to the concentrated solar power. But here what we are doing, we are using the collector plates. Here what we will be here, there will be a tower-like structure. In the tower-like structure, you can see that these are the collectors. It will collect the solar energy, and it will be reflected. These collectors are basically, I can't say collector, these are the reflectors, like mirror-like structure. This reflector will reflect the solar energy to a specific point where it will receive, that is basically collector. It will receive the heat energy, and and the pipe will, the metallic pipe will move through that heat and that receiver. And in this way, the cool water will flow through that, and the hot water will be generated, and through a steam drum, and through that steam drum, the turbine can be rotated, and a generator is used to generate the electrical power from the rotation of the turbine, and the electricity can be generated. This is basically the working principle of a concentrated solar power. So there is the establishment. You can see that a full capacity test in the down. You can see so here solar power plant is being, the concentrated solar power plant is established in China. This is a photograph of that. So by which we can generate the solar power. Now comes the basically the photovoltaic solar power. Now this photovoltaic solar power plants are installing the solar panels. These solar panels are the arrays of solar cells, which will directly convert the electric, solar energy to electrical energy. So through that energy, what we will do, whatever the energy that has been electrical energy that is being generated by a solar panel or the solar PV system is a DC power. But most of the appliances, or the consumers mostly require the AC power. So what we used to do, we use some process, like we use the inverter. You can see that you might have everybody, most of you is having inverter in your house. UPS connection is there. So what do you use? You have a battery of Exide or any Amron. You might have purchased a battery, and you have purchased an inverter. That inverter is basically converting that DC power to AC power and supply to your appliances like fans, different loads that it is being connected to your house. So that is what basically an inverter will do, and the inverter will supply the power to the different area to the consumer. So this is basically the source of through which, or the photovoltaic solar power plant, which is generating the power. Okay. So now, we have studied about basically, if you see that 3 different technologies that has been, used for generation of power, electrical power from solar energy, is most of the convenient form of energy that is being generated is your photovoltaic solar power plant. I told you this is very convenient and easily it can be installed. It is decentralized. Installation cost is very low, and then that of the other. If anybody wants it can be installed in a low scale to a high scale. So it is possible, and it is very convenient to everyone, or for a consumer to install in their house also, in a colony also, in a village also. So it is possible. That way it has an advantages. But let us see how these photovoltaic solar cells are working to give us the power. So this is what the concept of being, photovoltaic cell through which we can generate electrical power. It is basically, whenever the sunlight is, or you can say the electromagnetic radiation is consisting of very small unit of light, we call it as photon. Everybody knows that when the photon, basically a source of energy, is incident upon this solar photovoltaic cell. So when a photon in the form of sunlight hits or strike the p-n junction of the solar cell semiconductor material, the energy from the photon dislodges. That means all the charge carriers become energized, and any free electrons within the p-n junction, as they become excited by the photons, it is become energized. Like basically we know that for n-type it is electrons, and p-type it is hole. So the result in the electrons being released and able to move freely across the depletion regions. So this is the mid one is the depletion regions. So they will start moving and leaving in a place a hole or a positive charge. So in a p-type material, these free electrons easily cross through the depletion layer. If you'll see that they can easily cross the depletion layer into the n-type material. So this movement of electron is one way. It will move from p-type to n-type, as the electrons are not able to cross the depletion layer back into the p-type material. It is only in the one way. So as a result, an excess of free electrons built up in the n-type semiconductor material, creating an electrical current within the solar cell. So it creates an electrical current Whenever the load is connected across the PV cell, the charges start moving towards the through the load. So that is how the a PV cell cannot work without any connection of the load. So there is no power, or we cannot get any power if any load is not connected. What do you mean by load? If because in we usually you can say that when we use in electrical engineering, we call it as a load. Load means we can say that any bulb or any device that is being drawing power. That means your AC, which is not a generating energy or power, it is consuming power. So your AC, your bulb, your motor, these are the loads which is whenever there is a DC load which can be connected externally to the device, can the electrical current can pass through this and the power can be generated. So this is basically the operation of a photovoltaic cell, by which directly we can convert the electrical power or solar energy to electrical energy. So this is one of the most important and very advantageous feature of this PV system. In case of a other two technology, you see what we are doing, solar energy is collected, it is converted to heat is being converted to steam is rotating the turbine is again from turbine rotation to electrical energy. You see, in multi-stage the energy is converted, the energy conversion occurs. So due to this multi-stage energy conversion, the amount of energy is the amount of loss of energy is more than that of this. Here there is no multi-stage conversion. Here directly the solar energy is being converted to electrical energy. So because of this, and another is the installation cost, and many factors are there which makes this PV system more attracting, or it attract to the consumers to use it for their convenience. So let us see that how these PV cells are connected. So because we have when we talk about cell, it is the first, you can see very small cell. I may be getting in microampere current from this PV cell, micro or nano ampere of current that I can generate, but I require minimum some ampere of current, like your devices, maybe to run these devices I require 10 ampere or something with 240 volt. If your AC is there, it is nearly current 12 ampere. So this much amount of energy that I require, the huge amount of energy. How can I get it? Because I am talking about PV cells. Now I will do all these PV cells, I will arrange in series or in arrays, in parallel and series, I will connect. So all those, to increase the current, what I will do, I will connect it into the parallel connections. To increase the voltage, I will connect them in series. So in this way, I can make modules. You can see the figure. So by combining this PV cell, we can make the PV module. By combining the PV module, I can make PV arrays. So in this manner, I can increase the voltage. At the same time, I can increase the current, the amount of power that I can require for my appliances. So this is how I can use this PV cell into PV module, then to PV array to generate a huge amount of power. It is possible to generate the power in gigawatts. So it is generated because it requires a huge amount of installation of this PV arrays. Now you see, these are the PV arrays. So what are we getting the power very, because we know that whenever the power is incidenting upon this PV array, are we smoothly getting the power, or is there any issues with this? Let us see, is there any issues with this? So one of the issue is the photovoltaic shading. What do you mean by shading? Shading means, shade. We know that there is a shading effect. The same shade means, because whenever there is a sunny weather, you used to stand below a tree. So why we used to stand below a tree? Basically to get the shade. That is the concept. What it happened to, but it has a disadvantages with the photovoltaic shading. What is that? If there is a photovoltaic array, if there is any tree, or anything or any cloud, or basically not cloud, basically T, or any of the devices, or any material which is blocking the cells in the, because we know that the solar arrays are a combination of many solar cells. If some of the cell is being hidden or shaded, then what it creates, is there any hazardous thing happens? So let us discuss on that. Like, because we know that whenever I'm installing anything, because when I'm installing a solar power panel, solar panels or solar arrays, my objective as a consumer, if I have invested some amount of money, so I require that my solar photovoltaic system or a PV system should work efficiently. The performance must be optimum. I should get the amount, because the solar energy will be incident on this, and the amount of energy that I should get in electrical form of energy should be optimum or maximum. How can I get it? So what are the external factors are there? One is environment, temperature, humidity, positioning, solar radiation. So these are the some of the factors which degrades the power, or also it affects the power generation. So environment, I cannot do anything. Some cloudy weather, what can I do? I cannot do anything. I may not have the power. If the temperature is less by the sun, what can I do? I cannot do anything. Humidity is less. It is not in with me that to control the humidity of my environment. But I can. And the next one is called positioning, and the degree of solar radiation. That also I cannot do. Only that one thing is, one factor is affecting, or one factor is controlling, that is which is in my hand, is called positioning. Positioning means, you see that one photo is there. So some of the shade is that some of the some leaves are there, which is giving shade to this some of the cells. Now what is happening to, if these cells are there? What is that? I explained that one. If the cells are being blocked by the leaves or trees or by buildings or by antenna, what is happening? Are we get the optimum or performance of our cell will be there? 1 minute, just now you see, if there is a blockage of by leaves or trees or buildings or antennas, are we getting the best performance from my solar photovoltaic system? Let us see that what is happening. So you see, now I have connected 3 solar cells. I have taken the small cells. Okay, so let us not go to the electrical aspect of this. I maybe the audience may be from the may not be from the electrical backgrounds. So let us understand first in a very simple way. Three cells are connected. Now you see that current is flowing, and there is some voltage drop across each of the cells, and the total voltage that we are getting from that, the total voltage thing by this one, that is 1.34. So if you see, there is a graph, there is a there is a graph for this voltage and current. You see, this is the characteristics, VI characteristics of this solar cell. Wherever the solar only cell 1 is connected, you see that the voltage is 0.5 and the current is fixed. Okay, same current will flow because all these cells are connected in series. So when this another cell is connected, now I have increased the solar voltage to 0.1, and you see the current is increased. And again, if you are increasing another cell 3, you see the current is same and it has been increased. Now you see there is a point in the graph. You see it is maximum power point. That is the maximum power that can be generated by the 3 cells, that we call MPPT, maximum power point. What is maximum power? Let us go. What is power? Power is nothing but called voltage into current. That is VI. So here we are fixing a current but increasing the voltages. All those 3 are connected in series. Now you see, let us go to the. Now let us go to the, this is what if one thing will happen, if one of the in between the cell will not work. You see, if the cell becomes shaded means it will be obstructed by a tree or obstructed by a antenna or something. What is going to happen? You see, it will stop producing the electrical energy. It is very convenient. Now, if the PV system, because we know that the solar system, the solar PV cell or a solar photovoltaic cell, a simple PV cell, whenever there is no power incident upon this, it will behave like a semiconductor resistance. Resistance means it will oppose the flow of current. So so what will happen if the whatever the current it is flowing through the circuit, that circuit will be opposed by the cell. The total amount of energy produced by the photovoltaic cell is strongly hampered. Now what will happen? The amount of power that will be generated will be very, very less. So that is what it is happening. Okay. So in case of a simple shading of a cell will be obstructing the total, or it is disturbing the total amount of power, or it will decrease the total amount of power that is being generated by the PV panel. You see, simple one leaf will block the system. One shade will block the system. Then you can see this is what the series connected. I am not explaining because IV characteristics I already explained you. So now you can see that how it is obstructing. Here you will be able to see that the first figure. You see that the cell 2 is shaded. Now cell 2 is shaded. Through that cell, it will be acting as a semiconductor resistance. Now it will not work. It will not work as a current generator. It will work as a semiconductor resistance. That means whatever the current it has been generated by the cell 1 and cell 2 will be obstructed by him. Now you can see that amount of power that can be generated, it is completely reduced. Are you able to see that due to cell 1, how it is reduced? Cell 2, it is reduced due to cell 3. That means the amount of power that has been reduced only because of a small shading, the total power is, is disturbed or decreased. Okay, so that is what we eventually call it as a bad cell, or we can say hot spot. We can say that hot spot or a bad cell. To take care such thing, what should be done? Now you see this is happening. Now you can say that many due to the shading in a simple one cell, it is completely disturbing the whole system. Now what to do? Now how can we protect a photovoltaic cell or a panel, even a full array, from a destructive effect or a partial or a full shading? Now what I require? I require something, a protective device which will bypass the current if one. That means like you are from your home to your institute. When you are moving, you have many roads. Okay, if there will be only one road, and in one of the road, and there is a municipal corporation, people have started digging that road for drainage maintenance. What you will do? You cannot go to your institute, so you have to apply for a leave. So that is the effect what it is when a simple one road is being one cell is being affected by shading effect. Now if you have another road to go, if you have a bypass road to go, what you can do? If one road is being obstructed by the municipal corporation people, then what you can do? You can choose another road to reach to your institute. That is what the way that you will do. Similar way we will do like this here also. What we can do? We will use a bypass diode, because if it is not we know that diode is a simple device. You can say unidirectional device. You see that what we used to do? We used to use the bypass device. Whenever any of the cell is not working, I will give a path to the current through another bypass diode. That means I have other cells are working. I can generate the power using other cell 1 and cell 2. May not be the power which is generated by cell 2 is not accountable for me. I don't require, because it has been shaded. So that's why what I will do, I will go for a bypass diode in each of the cell. This arrangement will make our effective to get maximum power from the solar array. Though there will be a obstruction by the shading effect, like by leaves, by antenna, anything will happen, but it will not affect it will not much affected by the power that has been generated by the solar array. So this is what the approach that we used to do. Okay, now, so we can see that we have seen that all those advantages are there with the PV systems. Let us see that what are the advantages of the PV system as a renewable energy source. There are no moving parts, unlike the conventional energy sources. Here, you see the PV panels are not moving parts. So it is like a conventional, it has a moving parts. So, but here there is no moving parts. So maintenance cost is very less. You can see that the cost that has been associated for maintenance, if you will install for, nowadays, many nanomaterials are there through which we are making the PV system. It is, auto cleansing effect is also there. So in auto cleansing effect, what will do, whenever there will be raining, so it will automatically clean the surface of the PV system. So that you can read in the literature, there is a due to this auto cleansing effect of the PV system, PV panels. So no fuel is necessary. This eliminates any environmental impact. So it has no environmental effect. We don't require any fuel for. It is long time. We can use it for longer life. Modularity is there. You can see that in now your house, you require a 1 kilowatt of power. Now what you have done, you have brought one AC, and you have purchased one big TV, and also you purchase some new appliances for your home. Now what you can do, you require all those powers can be taken care by the solar photovoltaic system. You are not happy with the grid, because sometimes there is a the grid, you have a power failure from even in the evening. You want to use more loads during the evening hour. What you can do, you can purchase some batteries, then all those batteries can be charged in the daytime through that photovoltaic system. If I want to increase the load, I just have to purchase another array or another panel and connect it in series or generate, or in parallel to the existing to generate more power. So in this way, it is having a modularity effect through which I can increase the requirement. My requirement can increase. I can use just one. By adding the panels, I can increase the. Another one is a decentralized power generation. So the most important thing is that it is decentralized power generation. It doesn't need any area where it can be done in a centralized way, but it can also be done in a decentralized way. Like you want to do it for your individual purpose, or for your institute wants to generate power from the solar panel. They can use the solar PV systems in their rooftops of the in the rooftops, and they can use the solar panel and generate the power. And all the lights in the hostels, all the lights in the classrooms can be connected with the solar panel, so that we don't require the our dependability of with the grid power will be minimized. So minimized visual intrusion can be integrated with the structure such as so visual intrusion can be minimized. So these are the advantages of PV as a renewable energy sources. Now you see that we will see now what are the challenges. We discuss all about our what are the effect and what is the advantages, but is there any challenge with it? You can see that let us, because we researcher must search the problem, not the solution. Okay, solution is the next time, because if we have a good problem, then we can find the solution. So what we can do, let us find that whenever, because I heard about everything good about till now I talk everything good about PV system. Let us talk about what the bad thing it has. Okay, only if you see the literature says, whatever the literature says, that it is nearly 15% to 20% efficiency. That means maximum efficiency is 15 to 20, whatever the incident power it has, incident energy from the solar, but we will be able to convert in a 15 to 20%. So in such a situation, the most important things, and sometimes it is very, very less also, not 15 to 20% also. So in such situations, you will find whenever we have installed the that PV system, if the efficiency is very, very less, then the things the challenge come to us that how we can get maximum power with this existing technology, existing PV system, how we can increase. So before going to this, I will talk about that. I want that like we all are working in some like some organizations. Okay, now our boss wants that how the any employee should perform well. Perform well means the employee should give the maximum, the performance will be best or optimum. Okay, how it can be possible? Unless and until boss will know me, if the boss knows that what I require from the employer, I cannot give my best performance. If I have to give my best performance, the employer has to give the best thing to me, the best input to the me, or to me, such that I can perform best, my best. Then only similar way, if I want that the PV system should perform best, how it will perform best? When it will perform best? When it will give us maximum power. That is what the performance index is here. Whenever the PV system will give the maximum power, then only I can see that my PV system is performing best. Okay, so let us see that how it performs best, and when it will perform best, and how I can make the PV system to perform best. It's not like that the PV system will automatically perform best. We are the researchers, we will work in such a way that the PV system will work to give us the best. So how to do? Let us know the basic principle to give the maximum power. We know that the in 1840 the Jacobi law is there. What we call we have the law that is called maximum power transfer theorem. There is a maximum power transfer theorem. What it says that whenever the source, basically source means energy source, is connected with the energy load. That means load means which require energy, another which generate energy. That is what load we call, which require energy, like a bulb, like a fan. These are the loads. When a load is connected with a source, that means which generate energy are connected to each other, and the impedance, the internal resistance or the internal impedance of both the energy source and the load are equal, then only the maximum power transfer will occur. That means maximum power will transfer from the source to load when both of the internal resistance, or you can say the internal impedance of the load and the source matches. So this is the law. Now what is the law with us? The law says that whenever the load impedance is equal to the source impedance, then only our internal impedance of the source and the load are equal, then only the maximum power transfer will occur. Then we see that when we will be able to do it. I cannot do it. No, we know that the PV panel, without, you see, there is a PV connected in your home. Unless and until you will connect a load to it, unless and until you will connect a battery to it, it will not give you the power. That is the beauty of this, or you can say beauty on this is the disadvantage of, unless until the load is connected to it, it will not give the power. So whenever how can I make the impedance of the load to equal to the impedance of the source? Source is our PV panel, load is all our loads, electrical loads. Now this has to be done. How I will do it? How can we possibly make the load impedance and the source impedance equal? So this is the challenge that we have. Then only the maximum power transfer will occur. So before giving do that one, let me give you one example. Okay, now I want that. So let us take an example of a diabetic patient. Okay, now what is basically diabetic patient? So we know that somebody is having a sugar level in the blood is higher than whatever it is desired. That is what no. Now that person wants to, the diabetic patient wants that his sugar level must be controlled. How it is possible? What he will do? He will go to a doctor. So when he will go to a doctor, the doctor will blindly give the insulin to him or give the medicine to him? I hope he will never do like this. He will never, without judging or without verifying the person or the patient, he will never prescribe any medicine, not for a diabetic person, nor for any patient, for a COVID, for any other reason. So what he will do? First, he will verify that what is the sugar level. What he will do? He will ask that person to go for a sugar level test before food and after food and all those things. He will take the data from the laboratory data, testing data. After knowing the patient, he will judge the patient. Okay, this is when he eats the food. After this food, this is the amount of increase in the sugar level in the blood, and his age is this. He is a he is a 20 years guy or he is a 50 years man. So he will check all those characteristics or parameters of that patient. After knowing the patient, then only he will be able to prescribe the the insulin or the medicine for the patient. So now let us go back. Without knowing the patient, the doctor never prescribed the medicine. Let us go back to our work. Now we have a source, that is the PV panel. We have a load. What we require? The maximum power transfer will only occur whenever the input impedance internal impedance or internal resistance of the load is equal to internal resistance of the PV panel. So I have to know, because here I have to know the system first. I have to, because there you have to know the patient. Here I have to know my system. How I will know? There is a process. We call it as a system identification or system modeling. Modeling means we will model the PV panel, how the PV panel behaves. Let us go to the PV panel. So we will use a simple single diode model. I will not go to the aspect of the, that electrical aspect of the system, but I will go to that. This is how we will model the plant. Okay, whether whatever may be the discipline, we can discuss. We used to do, like if you are a chemistry person, you're a biological person, we used to model a chemical equation, we used to model a biological cell, or if a physics person, if you are modeling a pendulum. So all those modeling in a mathematically, we can model a reaction also. So here we can model a PV panel. So with some mathematical equations, I will not go to that in detail to the mathematical equations. From that mathematical analysis or from the analysis of the PV cell, I can study about the PV power. You can say that current, the PV voltage and the current or the power. You can see that we have done it in our laboratory. What we have done, the PV, we have varied the PV voltage. You will be able to see some hills are there, no? So dark lines are called the PV power and dotted lines are PV current. In the x-axis, I have taken the PV voltage, and in the y-axis, I have taken the power. Okay, what I have done, now I have changed the PV voltage, and you can see that the PV power is what is, if you study one of the line, I have varied the different irradiance. The irradiance has been changed, that irradiance of the solar. With the different irradiance, I have checked the PV voltage with respect to PV power. Now you see, with a particular irradiance, let us see what we are doing. When we are increasing the PV voltage, you see the PV power is increasing, and at a certain point it go to the maximum power. You see, are you able to see in one of the continuous line? Up to a particular level, you will go to a maximum. Again, if I am increasing the PV voltage, it is going down. Now you see, what is our objective? Objective is to get that maximum point. Okay, let us go to our previous study. Let us think that let us not forget about all those PV things and all those things. I will this is a small discussion. If we remember ourselves, how to get that maximum point in a function. So it is possible only by getting the first derivative of a function. If the first derivative of a function is equal to 0, it may be a maxima or a minima. I think we have studied in our class. So most of we have studied maxima and minima of a function we have studied. So if you can see that if I can find out the derivative of this function or change in the change in the power with respect to change in the voltage with respect to power is equal to 0, then at that point is the maximum power I can achieve. Okay, so from this I can achieve the maximum power. So here I have studied with the different voltage and current. So that is what the same thing that we can do with different irradiance we have studied with the temper, So now we require we have to develop on some device which will make because I cannot change the internal resistance of the PV panel, but I can change the internal resistance of the load. How can I do it? So let us do it. We have a device called the boost converter or a converter. You might have seen that converters are used, basically inverter, what you say in our house. We are using some inverters to convert that AC power to DC power to AC, AC power to DC. So this is what the device which can be used to give the additional or electronically I can change or add the equivalent amount of internal resistance to the load such that it will be equivalent to the internal resistance of the source, such that I can get a maximum power extracted from the source by PV panel. So this is what we have developed one. This is the maximum power, what I explained. What I can do, I can generate some power. We can vary the voltage control input, and in a device or DC to DC converter we used to. So this is basically the objective function, the change in power with respect to the impedance, we are making it to 0. So by this differentiation of the power, we will be able to find out the maximum power. That is what the first derivative of the power. So we are using to whatever the data we collected. So these data are basically the data, sensor data, which is noisy in nature. That's why we are using a filter. So from this is the filter data on filtered data. Okay, so this is the study of the panel voltage with respect to the solar panel output power. Same from this different irradiance. And this is the solar voltage with the solar panel output power, and this is the model of a boost converter. Now this converter this is a single phase converter. So what we used to do, it has 2 switches, and before giving a control, because this is the control, we have to model the converter. So we have mathematical, I'm not going in depth to the mathematical derivations, but this by modeling this boost converter, we will be able to use this converter to control the internal resistance electronically, which will make our source internal resistance to equivalent to the converter. So we have done some mathematical model. Then we have, from the model, we got a model which we call it as a state space model, but it is a mathematical model that we can understand. And this is the control structure or the block diagram of the proposed controller. You will see that the load is connected, the source is there. Where what we do, we use some sensors to measure the PV voltage and the PV current. So we are using a data acquisition system. This data acquisition, what it will do, it will give you the data in basically the measured data is in continuous domain. So it will convert it to digital domain for your computer programming. And from that, we have developed a model predictive controllers or a controller. This controller will see how much amount of internal resistance that we require, such that the equivalent internal resistance will be equivalent to the source internal resistance. This is what the controller will do. So for that reason, we have designed a model predictive controllers. So this is what the objective function. The objective function is to generate a control action, the change in control action, such that the total amount of change in control action is such that the internal resistance by the converter electronically, which we can be changed such that the converter internal resistance is equal to the internal resistance of the source. So this is what the controller is generated, designed, and one can You can say this is the setup, that experimental setup that we can do, from which we will be able to get the maximum power from the, from the solar PV system. So this is what it is, the emerging, many proposed works are being done to generate the maximum power. So these are the works which we compare and we got it, and you people can also work on this to get the maximum power from the PV system. So these are the results that we have got. But one thing that we have observed in our work, that whatever the controller that we have used is very costly. But whenever we talk about the installation of the controllers or installation of the PV system, we have to be very much concerned about the cost associated with the system, because we require there should be the renewable energy should be installed at every point of everywhere, such that in a village, from a poor to a rich person, everybody able to install the PV systems to generate the power. So this is what somebody can work on this to get the cost-effective version of the proposed controller. So these are some references that I got, and thank you very much. So thank you very much for your patience. I don't know how much I succeed. So am I audible?
Yes, sir. Yes, sir. Yes, you are audible, sir. Really, the session was very enlightening, sir.
Thank you, madam. But I don't know how audience will feel. I tried.
We have some questions, sir. So now,
yes,
with
sir,
your
yes,
permission,
yes.
I would like to take up some question answers, sir.
Yes, madam. Yes, madam. Maybe a query.
I think from audience, Praveen Thakre.
Yes, sir.
Yes, Praveen Thakre, sir. You can ask, sir. Praveen Thakre, sir.
Praveen, sir, you can start your videos.
Yes, sir.
Yes, sir. Anyways, by that time we have another question.
Yes,
sir,
yes.
What is the relation between power gain, voltage gain, and current gain of a transistor amplifier?
What is the?
What is the relation between power gain, voltage gain, and current gain of a transistor amplifier?
Basically, madam, we have not discussed about the transistor as an amplifier.
So this question is from YouTube, actually. That's why I'm asking.
Oh, okay. Nowhere we are in the, because we are talking about the PV system. So we are nowhere in the transistor here.
Yes. Okay.
Yes.
Another question is there. What are the disadvantage of photovoltaic shading?
Photovoltaic cells, no, madam.
Shading, sir.
Shading, no.
Shading.
So
yes,
you'll find that basically whatever we have discussed, the shading effect is one of the, if any of the leaves or antenna or any shading by done any of the agent to any of the cell, because when we are installing the panels, if one of the cell is shaded, then that cell will affect the other cell to get the current, because each cell works like a current source. So if one of the cell, because they are connected in series and also in parallel, but if those who are connected in the cells, those who are connected in series, if any of the cell is being obstructed by the shade, so other cells will not perform. What will happen? The current will not flow through that. It will work like a resistance. So this is what it is. It happens during the shading. So this is the disadvantage of this shading. Now to handle such shading effect, what we can do, each of the cell can be bypassed, or there is a bypass diode which will be connected in parallel with the cell. And whenever the current will flow, if there is obstruction by any shaded cell, the current will take that bypass and the equivalent performance will be retained. Definitely there will be a reduce or decrease in the performance, but it will not that much. Am I able to answer?
Yes, sir. Yes.
Yes, madam.
And another question is there.
Yes, madam.
What is the majority charge carrier in P-type semiconductor?
Madam, holes, I think. Holes are the majority charge carriers in p-type semiconductor.
Okay.
So
Okay.
these are the fundamental things that, you can get it. I hope from this, whatever the, anywhere they have to understand.
Yes. Yes. Okay, sir.
Yes, yes, yes.
Yes. Yes. From audience, Praveen Thakre, sir.
Yes, sir.
Praveen Thakre, sir. I think he has some network issue.
Okay, 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 madam.
So thank you very much, sir. It was very informative and enlightening session. It is my
Thank you very
pleasure.
much, madam. Thank you to the audience. I think with a lot of patience after, I think 1 o'clock to 2:30, it's very difficult. No, thanks to everyone for, interacting. It's really amazing for me to
Yes,
interact
yes,
with
sir.
you people. And thank you very
sir.
much.
It's my privilege to propose a vote of thanks on this occasion. I, Dr. Pallavi Mahalle, on behalf of MCT Rajiv Gandhi Institute of Technology and the Department of Applied Science and Humanities, organizing an online 3 days FDP of recent advancement in nanomaterials, green technology for sustainable engineering. And my own behalf, extend a very hearty vote of thanks to Dr. Das sir for accepting our invitation as a resource person and sparing his valuable time with us. Thank you so much, sir. Indeed, it was a session filled with a lot of information and good insight on the topic of maximum power extraction from PV system. Once again, thank you so much, sir. The feedback link for today's session will be shared through the WhatsApp group after the session, and it will be activated till tomorrow 10 a.m. All the participants are requested to submit feedback as soon as possible. Thank you so much.
Thank you very much, madam.
Yes, sir.
Thank you very much. Okay, then, madam, I'm leaving.
Yes, sir. Yes.
Okay.
Now you can leave.